once again. Just kidding.
That was got zeros.
Yeah, did she fix it?
I hope so.
So basically, with this chapter, confidence interval is how sure you are that's the right thing, but it's like in between two numbers, right?
Mm-hmm.
It's a
And
range
then
of
the
values.
margin of error is what the difference is between the number that
high
you
bound
got.
and the low bound.
Yeah. So it's not the distance between them, it's the distance between the main number and the high and the main number and the low. So, for example, if there's a margin of error of 3, it doesn't mean there's a distance of 3 between the high and the low. It means that there's a distance of 3 between the main number and the high and the main number and the low. So there's 3 between the main number and the high and 3 between the main number and the low.
Really?
Yep. I know because I literally just watched videos.
I watched the videos, but I guess I didn't pick up on that.
Yeah. It's true.
The assumptions for creating a confidence interval. It's interesting that the assignment asks that twice, so maybe that'll show up at a test at some point. Like a simple random sample is drawn from the population. X bar. What's X bar again?
What?
X bar. Mean.
Mm-hmm.
It's normally distributed, and then sigma is assumed to be known.
Mm-hmm. Sigma is the standard deviation.
Standard deviation is assumed to be known.
And then wasn't there the? Oh no, that was the other one where it said that one or the other was on the other.
Yeah, and then to get the numbers for the probability, which plug into the equation, it's just like the applet.
Yeah.
That's
And
all.
when
That's all you have to
when
change.
they were trying to get me all confused about that Z, they're saying, "Oh, we'll tell you what it is later." It's just the Z-score. That's all it is. It's not any different. You plug in the probability up top, and you get the Z-score.
So it's X bar, which is the mean of the population.
Yeah.
Plus or minus Z, which is the Z-score.
Mm-hmm.
And then sigma, which is the
It's
standard deviation
divided by the
sample
number.
size.
Like the sample size, a square root of the sample size, yeah.
Yeah, this seems really familiar.
Yeah.
I like most of this anyway.
It's pretty easy.
And then plus gives you the high bar or the low bar? I like the high.
Plus gives
or
you high,
bound.
minus gives you low. Pretty sure.
Yeah.
Yeah, because you're adding to get to the high and you're subtracting to get to the low.
Okay. Well, should we take the quiz then?
Let's just do it.
I think that's the assignment. So
I'm there. I'm in like Flint. Actively persistent.
48 questions.
Holy frick! No way. You're full of crap. Jerk. Not funny.
Find the margin of error for a 90% confidence interval when the standard deviation is sigma equals 50 and n equals 25.
Okay, I'm getting back up there now.
So
we need to plug it into the normal probability applet to get the Z-score first.
what is it? It's 90%? Okay.
So that'd be 90. And
Well, you have to take the middle is the thing.
yeah.
And then you have to plug the 9 back into that.
Yeah, but it doesn't matter. The Z-score is still the same.
No, well, if you put 9 into the
Oh,
top.
why did that change? That's
That's like great.
the Z-score is not the same. Why did that? What? Why is it freaking out on me right now? What did you get?
I heard it's kind of racist.
It is racist. That's what I've heard too. Okay, so it's 1.645. My goodness. Leave me alone.
Okay, 1.645. And then, so, okay, the margin of error is 90%, with standard deviation is 50, and n equals 25. So the sample size is 25, which the square root of 25 is 5, right?
Uh-huh.
So it's 5. So it's 1.645
So-
times
the point is to find the confidence interval and then find the margin of error from there, right?
Oh wait,
Yeah.
confidence interval.
The confidence interval is the exact same thing. So it's z.
Oh, because you're gonna find the
So the
high
mean
bound and
plus or minus the same thing, the standard deviation over
but we don't.
the
Oh, is
So
50
it's-
the mean? No, 50 is the standard deviation.
yeah
They don't
yeah.
give us
So
the-
50 this is the standard deviation. So what we're doing is the mean. I thought it was. I'm losing my marbles now.
Margin of error. Well, but what's the margin of error?
Is the thing. I'm pretty sure. Hey, what are you getting?
Yeah.
Okay.
It's,
So are you trying to find the confidence interval and then find the margin of error?
I'm just doing
Okay. Margin of error is z, which is that 1.645, and then we times it by the standard deviation over the square root of the sample size. That's what. So yeah, and then the confidence interval is the same thing, but you plus or minus that. So what did you get?
So
Still doing it.
yeah, because last time the TA told us that it was open book.
It's been open book this whole freaking time.
That's what she said to us.
That is the most gay thing I've ever heard in my life. Why didn't they tell us? There was no way of us knowing that it was open book.
Yeah, I don't know.
It wasn't
but-
in the whatchamacallit.
I don't know if that's just like
syllabus.
a TA's opinion or what, but
The TA tells me it's open book, I'm gonna use a book.
yeah. Yeah.
Doesn't say anything else other than that. So did you plug it in?
So the Z score.
So what did you
Okay,
get?
so we could get the Z score. So the Z score is 1.96, right?
Oh, the
and
Z-score is
It's 50 divided by 5,
1.645.
so it's that times 10.
So it's 1.645, and then you're gonna times it
60.
by the standard deviation over the square root of the sample size.
Yeah, which so the standard deviation
10.
is 50, and then 5 is the square root of 25. So 50 divided by 5 is 10.
Okay.
So then you times that by,
So 1.645 times 10.
I believe, yeah.
1.645 times
In my religion, that's how it'd be.
16.45.
And we don't know X bar, but we don't need to know it.
No, not yet. You need X bar for the confidence interval, I believe.
Is that what you got?
that's what I got, but I don't know why.
It's because we plug it into the formula. And that's what it is.
Well, it's because the margin of error is only that part of the equation anyway.
Okay.
Yeah.
Because, like, at least when they were doing it, like,
No, yeah, that makes sense because when we get the confidence interval, we're going to plug in X bar because we're trying to get what the high between the X bar and the high and between the X bar and the low. And that's why we're plugging in the X bar and we're minusing and we're adding.
yeah.
All right.
So which of the following
wow,
statements
this
is true?
Whoa, this scroll is killing me. All right, leave it. All right. So where are we? We're at
Standard deviation squared is the
What-
interval estimator of X bar. X bar is the point estimator of mu. Mu is the point estimator of X bar. Alpha is the interval estimator of alpha squared.
sigma is the interval estimator of sigma squared. Oh, this
I guess
Mu
yeah, it's sigma.
is
It's
a
not
point
alpha.
estimator. I think mu is the mean, isn't it?
Yeah, mu is the mean.
Then I think it would be mu as the point estimator because we know that the X bar is the mean, I believe.
What's the point estimator again?
It just means that number that you start with when you do predictions. I don't really know exactly why it is what it is. I just know it is.
Yeah.
So look, does it say what X bar is?
X bar is just
Yeah, so that's what that would be then, because mu is mean, right?
It says
You know for sure mu is mean, right?
Yeah.
Okay, that's interesting.
Well, no, mu is the mean of something, but the mu of the population or the mu of the sample.
Okay,
Or the mean of the
well, we
sample,
know
or-
that mu equals mean in general,
But,
as far
but
as
the
I
key
remember.
the key word is interval estimator and point estimator. Because that's
true.
from the chapter and could be easily controlled F.
Yeah, but the point estimator is the X bar. I know that for sure. I don't know for sure if mu is the point estimator of X bar, but I know that the point estimator is X bar. Like, X bar is the point, not the interval estimator. I know that. Maybe we should just.
I think it's the second one.
But what is
Do
a
you
point
think that
estimator?
X bar is the point estimator of the mu?
Yeah.
Okay.
But
It says point estimator is one number. Just to estimate a parameter. And it says right here. It's the parameter.
Okay.
So it's saying that is the.
It's either one or the other. It's hard to know which one.
but okay, but what's the logic behind it? So
Because X is a simple point, and U, the mu, is it's saying it's the population parameter used to the number that's used to estimate.
okay, and then a parameters and statistics, like I still don't understand the distinction between that. I know they
I don't
explained it
either.
3 times. It's like
It's either one or the other. I don't know. I'm certain it's the second one. But
I'll
it's
go with
not
the second one. You have some
X
sort
bar
of
is a point
evidence to back it
estimator
up.
of mu.
I would just-
Gina wants to construct a 95% confidence interval for a GMAT score. So the
So
first thing
what
with
is
that
the
is
point
95.
estimate for the true GMAT score? So the point estimate is the X bar. We know that. Okay, and in order to find
Standard
the
deviation is
Z,
115.
we would plug in 95 up here. We know that much.
Simple
that.
random sample size.
So the Z score would be 1.96. We know that much. Okay. And use the information for the next 6 questions. Okay. So what is the point estimate for the true GMAT score? The point estimate is the 526. It's this. Yeah. They're just having us do this really simply. They're not making this really complicated. What is the margin of error for? So now we do exactly what we did before. We would do the Z score, which is 1.96, I believe. Double check. Yes, 1.96. And then we're going to times that by the standard deviation over the square root of the sample size. Square root of the sample size would be 8, right? 64 square root is 8.
Yeah.
Yeah. So standard deviation divided by 8. 113 divided by 8 equals, and we times that by 1.96.
I got 27.685.
Yeah, that's what I got too. And it says round to what? Make sure that we're rounding this. It doesn't say.
What is the lower limit of this confidence interval? So we take the minus? Yeah, I guess that would make sense.
Did you say 27.685 or did you?
Yeah, that's what I said.
Okay. So literally what it is the X bar. So it's 526 minus the 27.685 would be 498.315. Is that what you got?
Yeah, that's what I got.
Is there anything up here that tells us where we're supposed to round to? Do not round until your calculation is complete.
So the width of the
Please remember to round to 3 decimal places. Okay, cool.
The width of the confidence interval is Gina increases the sample size. I guess that's easy to figure out because all you gotta do is
Yeah, so we go back up now. We're gonna do
498.
The plus. What did you get for the
It
high?
increases.
What did you get for the high?
The high.
The high. The upper limit?
I got 553.685. But is that what you got?
I didn't do
Or
it
anybody
because
else?
it's literally math, like
Yeah, it's
adding.
just adding,
So I trust that you didn't put it wrong. What would happen if the width of the confidence interval if Gina increased the sample size?
It decreases,
So it
doesn't
decreases, yes, because the confidence interval, you're going to become more confident as your sample size is larger.
But something gets larger the larger that you make it. But I don't know. I don't think it's that because
I'm pretty
I
sure.
just plugged in.
What would happen if
Well,
the width of the confidence interval if Gina changed it to a 99? So it's a 90.
It would
right
it
now?
would increase. The width would increase
Okay.
because that's talking about.
Wait, explain that to me.
Well, because it's like the normal probability output. See, look at this. So at 99% or 95% confidence, it looks like that. At 99, it looks like this.
Oh, yeah, you're right. Well, that's an easy way to know.
Bright bulb light
Which
company
one
is
I guess
fine.
that is. Standard deviation, they want 95 with margin of 50 hours. What sample size do they need? So this is algebra.
Yeah.
Yeah. So
But I don't know if
we find the z-score at the 95, which is 1.96, and then we just do exactly. So they want the sample size. So we're doing this. It would be the z-score is 1.96 times 400 divided by the square root of x equals 50 hours.
Divided by. Because something was squared. Because you take the
well,
square root out of the
how you do it,
denominator.
right?
Yeah.
Because if you have a square root, in order to get rid of the square root when you're doing algebra, you square it. So yeah, just write it down. I don't have this page. This is gay. All right, whatever. Just look at this real quick again. Why is this thing so retarded? Dude, seriously, taking an apple right now. It's not working.
All
right.
you have to do is get started. Click get started.
No, it the same thing happened before.
Well, if
So
you
I
click,
say get started, and then it wants me. I'll skip this. All right. So what I was saying, come on, anything to do. What I was saying is 500 equals 1.96 times. What's the standard deviation right now?
standard deviation is 400.
400 divided by the square root of SQX. So that's what we got, right? So would we do the square root first? So we do 500 squared to get rid of it? No, we wouldn't. We divide by 1.96 first, right?
Probably.
It says on here u times the z-score times standard deviation.
Okay, so that's what it's saying to do? Okay, so you want to plug this in real quick? Or did you do it?
No, I haven't.
So it would be 1.96 times, what was that? 400 divided by 500 squared. That's the answer.
Nice.
2.45. But it would be 2.459, right?
2.458.
But we're rounding it to 3 decimal places. So, oh no, round to the nearest whole number. Guess what? This is one thing that was weird on the homework.
Wait, you need a sample size of 3? Yeah.
This doesn't make sense.
Yeah, that doesn't make any sense at all.
Oh, that is weird, but that's what you said.
You lied to us.
Yeah, so
The number
the
that you
z-score is 1.96.
1.96.
The standard deviation is 400.
Yeah.
But you're squaring these, so you divide that.
Did you not square?
Wait, let me see.
Well, we know that the Z is 1.96. We know that the standard deviation is 400. And we know that the margin. Oh, that's no. Yeah, we know that the margin.
What is M though?
No, it's 50. That was my problem.
Yeah, you give me
Margin of
500.
error is 50, not 500. Sorry.
Now you're good. 245, so 246.
246.
The margin of error.
I just said
Oh,
500
because-
instead of 50. I just brain farted.
So what did we get then?
246.
246.
One thing that I noticed on the homework, when they say round up, they say that if you're at like a decimal place, I noticed it said something like 4.41
Mhm.
and they round it up to 5.
That's because you can't have like 0.4, you just have to go up to 1.
Yeah,
Okay, what is the lower?
closer to.
Yeah.
Okay.
Okay.
Okay, well, I'm done. Mean salaries, blah, blah, blah,
So I
blah,
told you it was the
blah.
mean.
What is the lower limit of this 95% confidence interval? So all we got to do is find that first thing again. So we do the 95 to get the Z, which
is
is
the lower?
1.96 again. And then we do 1.96 times the standard deviation, which is 36,730. And we divide it by the square root. Wait. You set up a hypothesis for them. Okay, I'm confused now. Okay. Mean salary of actuaries is the mean is 100,000. The standard deviation is sigma, which is 36,730. You're interested to know if your mean salary for women actuaries is different from the population, but are not sure. If it is higher or low, you set up a hypothesis with a level of significance of 0.05. And mu, so the mean equals 100,000, or it doesn't equal 100,000. Collect a simple random sample of 36 women's hours and find that the point is 111,000. Okay, that would be what I said it was first. I think it was getting it. It's going to get confusing, but not yet. So it would be the it would be the. It would be the 36,730 square root of the sample size, which is 36. I'm just no, don't say it.
Okay, so it's $88,001.
88.
So 88.
Okay, how do you know?
You just use that same formula, which is
Well, yeah. Okay,
Z.
so this is what I did: is I did 1.96, and then I did 36,730, which is the standard deviation, and then I divided it by 6, which is the square root of 36, which is the sample size, right?
Mm-hmm. What did you get?
And then I times this by that,
Oh, why don't you just do the formula?
which is what the formula is, isn't it?
I guess, but
And then you subtract.
if you just say equals 1.96 times the
Maybe if I, well, we're looking for the lower band, aren't we?
730.
Because I got 99,000.
Well, so what I'm doing is I'm finding the margin of error first, and then you can literally just do the mean, and you can, if we're doing the lower, then you do the mean minus, and if we're doing the higher, you do the mean plus. So that's what I'm doing.
Well,
Yeah. So then you would just do this, and then what's the sample size? 36.
what did you do for yours? 'Cause I just don't know where I would be wrong.
I put it so you do the z-score.
Yeah, which is 1.96, right?
Yeah. So first you have to figure out the standard deviation divided by the square root of the sample size,
Yeah, this is the standard.
which was
36,000 is the standard deviation, right?
What's up?
Like 36,000.
36,730
Yeah,
is the standard deviation.
Okay.
And then I take the square root of the sample size, which is 36.
Yeah.
Which is 6.
Yep.
And then I take the then I divide those two, right?
And what do you get for that? 6121.
Yeah.
Mhm.
So you'll
And then you
multiply
times that by the
by
1.96,
1.96. Yep.
Which is
and
what
that
gave
gives
me
you your
11.
margin of error. So that's your margin of error.
But then we take,
Then you
then
Plus you
mu.
subtract that by the mean.
so if you subtract it, then you should get 99,000.
Yeah, if you subtract it. Yeah.
We're
And
trying to
that's-
get the
okay.
lower limit
Yeah,
first.
and that's the lower limit, right? And then, okay.
99,000. Oh, so you already got the upper? Is that what you're saying?
I don't know. I just heard something about 88,000.
Wait. I'm confused. So we're 88,000.
But it's really not. So it's, I don't know.
100.
'Cause I think we're both on the same page as that, aren't we?
Yeah.
That's
Okay, so what did you-
$99,001.
$99,001 for what? Upper or lower?
Round to the holes. Lower is 99,000.
Did you get 99,000 for the lower?
Yeah, you just round it.
But would it be 99002? Because it's 5.
I don't know.
What is
Because
it?
this is 5 right here. So do you round up or down?
I would say 9900. 2. And then what did you get on the upper?
1, 2, 2.
Oh yeah, man.
Yeah, I got.
Oh, are
What?
you going back to that? To question 14? I don't know if I just.
There are 3 requirements to check when computing an interval for the mean. They are a simple random sample is drawn from the population.
X is assumed to be known, and the sigma is assumed to be known here, and then X is normally distributed. Yeah, it's all of the above. So we have one more, and that's the upper. So all we do is just the opposite. Did you get the upper yet?
Yeah,
What did you get?
I got.
What
I got that right there. 122,998.
8. 122,998.
Yeah.
Okay. Submit squid quiz. I want to see if you get it right. Just check.
200%. Yeah, I got
You
100%.
just round it up to the 99002.
Yeah.
You did.
I got 100% too. Cool guys. Good teamwork.